Hi everyone! I was thinking that we can never have too many effects for transitions between game screens, so I made a fairly simple one that lets us demonstrate a nice result with an easy formula. And how about this version? Does it look familiar? Let's take a look at how easily we can create this. This time we'll be working with an image again, so I'll create the usual scene that includes a screenshot from our game. So I'm right-clicking the scenes folder, create new scene. Let's make it a 2D scene and name it, for instance, stripes. Okay. And now this is the image I was talking about, found in JPEG, drag into the scene. So a sprite 2D node was automatically created, and in the inspector, let's do the usual stuff. So cancel centered for the offset, and at the transform position, let's reset it to 0, 0. And now let's scroll down to the material section, and I'll create a new shader material, click it, and create a new shader, which is of type shader. Mode is canvas item, and the name stripes.gd shader. I'll just put it to the shaders folder and create, and click again to open it in the shader editor, where I will, as usual, expand this panel, and I'll delete everything from the generated code that we won't need, leaving only the fragment function, deleting vertex and deleting light. Save. Okay, so we'll create this effect in several stages, going from simple to more complex, so we can better understand how it works. And since this is a transition, our main parameter will control the shift between individual states, taking values from 0 to 1, and I'll call it state. Let's put it here, uniform float state with a hint range, and the initial state would be 0, which means the start of the transition from 0 to 1, and let's make the step point 0, 1. Okay, as we saw at the beginning of the video, the effect is based on dividing our image into a certain number of stripes. We'll also control their number with a parameter, which I'll call stripes. Yeah, sure, why not? Uniform float stripes with another hint range, and let's start with 10 stripes, and it should go from 1 to, let's say, 100, and the step is this time 1. We don't want any fractional stripe, of course. Perfect. We can move on to writing the code. As shown in the beginning of this video, we'll shift half of the stripes to the left and the other half to the right. To achieve that, we'll need a function that returns values of -1 and 1 based on the pixel's y coordinate. Furthermore, it should return the same value for an entire stripe. So I'll switch to my web browser, where I have the Desmos app open, and will try to define such a function. So here it is, desmos.com, and I'll start with the function floor x. Okay, sorry, typo. Floor x, this is correct. As we know, the floor function returns the integer part of a number. So, for example, in the interval from 0 to 1, 1 excluded, it will return 0. In the interval from 1 to 2, it will return 1, and so on. We can clearly see this on this graph, which looks like a staircase. However, we don't want the values to keep increasing. We need them to alternate between -1 and 1, and for that, the mod function, which is a remainder after division, will help us. Let's adjust the function like this. So we will do modulo of this floor, and the division is by 2. Okay, that's better. but the function currently returns values of 0 and 1, while we want to return -1 and 1. So how can we achieve that? Very easily. Let's stretch the interval and shift it. I'll multiply the function by 2 and then subtract 1. So multiplied by 2, we can see from 0 to 2, and now -1, it's from -1 to 1. Now it's correct. But we mustn't forget that in the shader, we are working with the interval from 0 to 1, which corresponds to the range of UV coordinates. So we'll need to multiply the floor function's parameter by the expected number of stripes, like this. Let's use, for example, 10 stripes. So multiplied by 10. And now if I enlarge this, we can see it. So we have the final formula ready. I can go back to the Godot editor and rewrite it in the fragment function. Here it is. This time, it's enough to work with the regular UV coordinates. There is no need to shift the origin to the center or recalculate the aspect ratio. So let's do this. Back to UV is simply UV. And now float direction would be exactly as we defined the formula and the Desmos app mod of floor. And now we're working with UV. Y, the vertical coordinate, multiplied by parameter stripes. And we are dividing by 2, multiplying by 2, and subtracting 1. Okay, now all we need to do is increase the x-coordinate of our UV vector by the current value of state, multiplied by direction. And finally, we'll assign the pixel color at the modified UV coordinates to the internal variable color, which represents the output of the fragment function. So it would be this. UVX is increased by state times direction, and the color is function texture applied on our texture, which is the background image, and UV in lowercase. Okay, that should be it, and we can try it out. Let's display the whole image, and I'll open shader parameters in the inspector and adjust the state parameter, moving to the right. Now it's 1 and coming back. I guess it works as expected. And we can also verify that changing the stripes parameter increases or decreases the number of stripes. Can you see? 100, or going down. Now it's only 1, 2, 3, 4. Okay, I would say it works fine. So we've got the basic effect already, but what if we don't want a black screen to appear under the first image and instead want to show a second image? So first we'll need a new uniform parameter to which we'll assign this second image. I will expand the panel again and create a new uniform parameter. It would be simple uniform sampler 2D target. That's all. Now we have two ways to implement this transition. The first approach is to decide which texture to use for the current pixel based on its x-coordinate. So if it's still in the range from 0 to 1, we display the first texture, otherwise the second one. But first, of course, we need to assign something to this parameter, which is currently empty. And I will use our second usual image, which is called Chapel JPEG, and assign it to the parameter target in shader parameters. Okay, and now let's rewrite this. Or, of course, we can just put it after that. Color is, so let's, if UVX is greater or equal 0 and UVX, so it's simply in the range from 0 to 1. In that case, I'm using a ternary operator. We will use texture of our texture and UV recalculated UV coordinates, otherwise texture of the target texture, and this time the original UV coordinates in the uppercase, because we don't want the second image to be distorted. Okay, and now let's try it out. Again, I'm changing the state value, and we can see the second image right behind the first one. Works fine. Okay, and which might look even better, we can combine both images using the mix function with the state parameter value as the weight factor, like this. Let's do that. We are always rewriting the previous color, so it doesn't matter if we just put these lines one after the previous one. Mix texture of the first texture and lowercase uv. Now the second one, texture of target and the uppercase uv. And finally the state. Okay, and again, let's try it out, and we should see some fading out. Yeah, can you see it? And going back. This is nice. Okay, so how else could we enhance this effect? We can introduce a pseudo-random factor so that not all stripes look the same. To make the edges of the individual stripes more visible, let's temporarily switch back to displaying based on the x-coordinate. So I'll just comment out this line and this line. So this method is valid. Let's check it out. Yeah, works fine. I think we can leave it in this state so we can immediately observe the results. Cool. So now I'll add two parameters that we'll use to calculate the pseudo-random offset. The first will be a texture called noise, and the second will determine the power of the resulting deformation. So scrolling up to the uniform parameters section and adding uniform. Again, sampler 2D, let's call it noise, and this time I will add the parameter repeat enable, because the noise texture we will generate in the inspector is usually a square one, so we wanted to repeat it in all directions to cover the whole image. And the second parameter, uniform float deform, which will have the hint range and the initial value, for example, 0.1, and the range would be from 0 to, let's say, 4, and the step 0.01. Okay, and in the inspector, let's find the noise parameter and assign a new noise texture 2D to it. So it should be right here, noise parameter. I'll just expand this column a little bit. Clicking and adding noise texture 2D. Let's click it again, so it opens new parameters. And in the settings, we'll set fast noise light to the noise parameter. And let's check seamless. It's on. For now, the default fast noise light settings are sufficient, but if you like, you can play around with the other parameters as well. So we'll simply click this one and change noise type, frequency, fractals, and so on. Anything you want to. Okay, so next we need to sample a value from this texture. Since we'll be working with a float type, we only need one color channel, for example, the red one. So let's insert this line of code. I'm scrolling down to the fragment function and I'll add it right here. Okay, no, before that, because we'll need to use it to shift the UVX coordinate. So float shift is state times texture of our noise texture, and I'll use that, then I'll explain it. Vec2 0 and UVY. Okay, and as I said, the red channel times deform. Okay, so as you can see, we're multiplying it by the state value. Otherwise, the image would be distorted even before the transition starts, because when the transition starts, state is 0 and cancels out this shift value. Okay, and multiplying by the deform parameter determines how much individual pixels will shift along the x-axis. And since we want a uniform shift across the whole x-axis, that's why I'm using just a constant here, 0. So we would take the noise texture only from this column, the first column in the noise texture. Okay, so now we'll just need to adjust the following line to take the shift variable into account. And it means we will use state plus shift times direction. Okay, and if we zoom in, we can already see that it works fine. The stripe edges are deformed, and if I just zoom out to the original image and work with the state value again, we can see how it's being deformed across the state transition. All right, and of course, if it's not enough, we can increase the deform parameter, and now it's even more deformed. So it looks pretty interesting. Okay, let's get back to the original values. But how can we achieve the effect we know from Doom? And I mean the original game from 1993, not the modern remake. Very easily, we can set a constant direction and simply swap UVX with UVY everywhere and vice versa, like this. So let's get back to the code, and first let's create a constant direction -1 and comment out this, so all stripes would move in the same direction. And as I said, swapping, so here we have UVY, let's changing to UVX, here should be UVY, and finally UVY and UVY. Okay, that should be it. Let's try it out. Yeah, seems to be working, and seems we need to use the deform value. Now it's nice. Can you see it? And of course, if we go back to using the mix function, the result will be also quite interesting. So I'll comment out this and return this line, and now we can see the blending. Very nice. Yeah, I think it looks cool. Great. So it's entirely up to you which approach fits your game better. Thank you very much for watching. Of course, the changes to the state parameter that I adjusted manually will most likely be controlled by a script, which ensures a smooth transition only when the game actually requires it. And as I mentioned, further adjustments to fast noise light could lead to more unusual deformations, which is also an idea for additional experiments. In any case, I hope this tutorial was useful, and once again we've shown what can be achieved with a relatively simple code. So, take care, good luck with your projects, and I'll see you in the next video.